This LOS is define, calculate, and interpret Macaulay, modified, and effective duration. Interest rate risk on fixed rate bonds. Macaulay, modified, and approximate duration. The duration of a bond measures the sensitivity of the bond's full price, including accrued interest, to changes in the bond's yield to maturity, or more generally, to changes in benchmark interest rates. Duration estimates changes in the bond price, assuming that variables other than the yield to maturity or benchmark rates are held constant. More importantly, the time to maturity is unchanged. Therefore, duration measures the instantaneous, or at least same-day change in the bond price. The accrued interest is the same, so it is the flat price that goes up or down when the full price changes. An equal change in rates will produce a greater percentage change when rates decrease than the percentage loss produced when rates increase. Okay, we're going to look at the graph now, which illustrates the concept of duration. So on the y-axis, we've got the price of the bond, and on the x-axis, we've got the yield to maturity. So the starting point would be the where we're at par. Let's put that at 100, and this would be the yield to maturity at par. Okay. Now we know as interest rates increase, what's happening to the price of the bond? It's going down. As interest rates decrease, what's happening to the price of the bond? It's going up. Now we learned that in a previous LOS. We looked at an LOS where the learning outcome statement was identify the relationships among a bond's price, coupon rate, maturity, and market discount rate yield to maturity. Now we did that in the introduction to fixed income valuation, but we didn't deal with the graphs. Now we are. We learned in that learning outcome statement that an equal change in rates will produce a greater percentage gain when the rates decrease than the percentage lost produced when rates increase. Okay. Now the reason for that, and that's why I said with the CFA program with the curriculum, sometimes you're working on that introduction to fixed income valuation, you're getting on top of it, but then later on you sort of cover the same concepts again. Now through the learning outcomes on duration and seeing the graph, you go back and recycle to the previous LOS and it becomes easier. And that's why I always say you have to have patience with regards to your study plan. This is a perfect example why, okay? Because in the previous LOS, we're learning these rules, but we're not really digging more deep into the facts on it. So here we can see why is that? It's because it's not a straight line. The price yield curve is not a straight line. It's a curved line, okay, with regards to bonds. And the curve is a little bit different on the top half than it is on the bottom half. And because we have two concepts here, it's going to be duration and convexity, okay? But nevertheless, with that, because of the curve, there's a curve, it means that an equal change in rates will produce a greater percentage change when rates decrease. So we're having a greater percentage change here than when they increase, okay? And it has to do with the shape of the curve, the price yield curve. It's not a straight line. So just to re-emphasize my point, this is the slide that you've already seen before if you've been going through the videos in order of sequence. That's why I wrote down here, recall. We've seen this before, okay? This was from the LOS, identify the relationships among a bond's price, coupon rate, maturity, and market discount rate. And we saw here with bond A, the coupon rate was 10% when we started with the price at 20%. When the interest rates decreased, the price went up to 60.95, okay? And the percentage change was 4.95%. And that was, so same percentage change here, but the price went to 21%, it went up. And the price was 55.405. The decrease in the price was 4.6%. So we can see that the greater percentage change was when the discount rates went down. 4.95% was greater than 4.6%. So we saw that in the previous LOS, but we didn't look at the yield to maturity, here where we had the price and here where we had the yield to maturity. We didn't look at the graph. And the reason for the difference in the percentage change has to do with the curve, the price yield curve, okay? It's not a straight line, and that's why. So as I said, you move forward and then you move back and review and recycle, and it all starts to become a little bit easier, okay? So you should recall this graph. I won't go through it all, but we had the 4 rules. You know, the percentage change is greater when rates go down than when rates go up. Then we looked at for the same time to maturity, 20 years, the lower coupon bond has the greater percentage change. And for the same coupon, 20%, the longer term bond has the greater percentage change. Okay, that's a review. We're recalling that. But the shape of the curve has to deal with bond A here, that as rates go down, you've got a bigger percentage change than when rates go up because of the price yield is a curve. Do a quick practice question here to check our understanding. An analyst determines that a 5.5% coupon option-free bond maturing in 7 years would experience a 3% decrease in price if market interest rates rise by 50 basis points. If market interest rates instead fall by 50 basis points, the bond's price would increase by A, exactly 3%, B, less than 3%, or C, more than 3%. Okay, you can see the correct answer is C, because it says if the market interest rates instead fall by 50 basis points, the bond's price would increase by more than 3%, because remember the rule, an equal change in rates will produce a greater percentage change when rates decrease. So decrease, fall. Then the percentage loss produce when rates increase, okay? So the only trick with these questions is you have to be careful when they're saying most likely, least likely, increase, decrease. Sometimes you may want to just write down, recreate your notes as if you're creating your own flashcard and write it down before you answer. Don't always do everything in your head. It's easy to make a small mistake when it's, less than, more than, most likely, least likely. But in general, if you know this rule that an equal change in interest rates will produce a greater percentage change when rates decrease than the percentage loss produced when rates increase, this question should be very easy in less than 90 seconds, okay? The bond is option free and therefore will exhibit positive convexity. An equal change in rates will produce a greater percentage gain when rates decrease than the percentage loss produced when rates increase. Easy, we've seen this. Before we go back into my slides, I just wanted to take a quick screen capture of where we are in the text here. Interest rate risk on fixed rate bonds. So this section is talking about Macaulay, modified, and approximate duration. So there's a little bit of information about the duration of a bond's, the duration of a bond measures the sensitivity of bonds, full price, etc. We cover that. And it talks about the duration being divided into yield duration and curve duration, okay? Yield duration is the sensitivity of the bond price with respect to the bond's own yield to maturity, and curve duration is the sensitivity of the bond's price, or more generally, the market value of financial asset or liability with respect to a benchmark yield curve, okay? The benchmark yield curve could be the government yield curve on coupon bonds, the spot curve, or the forward curve, but in practice, the government par curve is often used. Yield duration statistics used in fixed income analysis include Macaulay duration, modified duration, money duration, and the price value of a basis point, which we'll see in a LOS coming up later, okay? So a curve duration statistic often used is effective duration, and it's going to be covered a little bit later. Anyhow, the reason why I'm showing this is that this section of the text just then jumps right into the Macaulay duration, and you can see, it's hard to see right now, but I'm going to go to my slide, and I've got the formula here. In practice, there's not a lot of, I haven't seen a lot of practice questions where you have to calculate the Macaulay duration, but they start with it, okay? And the Macaulay duration is named after Frederick Macaulay, the Canadian economist, who first wrote about the statistic in a book published in 1938. So the equation is a general formula to calculate the Macaulay duration of a traditional fixed rate bond, okay? So you can see the denominator, I'm skipping down to the bottom, is the full price, present value full of the bond, including accrued interest. It is the present value of the coupon interest and principal payments, with each cash flow discounted by the same market discount rate, okay? Okay, what I've done now on this slide, I've got all the formulas for Macaulay modified in the approximate duration. So we're starting with the Macaulay duration. As I said, we saw that on the previous slide, and I wanted to take a quick shot from the ebook to show you that that's what they start with. And there's quite a few variables in that equation. And in general, I haven't seen any practice questions or too many practice questions where you actually need to calculate it, you know. In that case, maybe it's guess B. What I have seen more commonly is to calculate the modified duration. You can see the numerator is the Macaulay duration and the denominator is 1 plus r. So you can see here it's a lot simpler. They could give you, if given the Macaulay duration and you need to calculate the modified duration and you've got an interest rate, you can do that. That's a lot easier, okay? Where we see lots of practice question is on the approximate modified duration. And here's the algebraic formula. The present value negative minus the present value positive. What is that saying? I put it here in words. It's the price if the yields decline minus the price if the yields increase. And in the denominator, we've got 2 times the change in yield in decimal times the initial price. Okay, so that's a formula absolutely 100% you need to memorize, and we're going to see practice questions on that. And what is it says here, the objective of the approximation is to estimate the slope of the line tangent to the price yield curve. And we saw that in the previous graph. We didn't talk about it a lot, but there's a slope of a line that's tangent to the price yield curve. The best way to get on top of the duration questions is just to practice. Do as many practice questions as possible. So that's what we're going to do. The first one we're going to look at is an analyst determined that if interest rates increase 120 basis points, the price of the bond would be $89.70. But if interest rates decrease 120 basis points, the price of that bond would be $99.30. If the initial price of the bond is $95.40, the approximate percentage change for a 100 basis points change in yield is closest to A, 2.5%, B, 4.2%, or C, 8.4%. Okay, so they're asking for the approximate percentage change, okay? So we know we're going to use this formula. The formula for calculating the duration of a bond, estimated percentage change for 100 basis point change in yield, is here. So there's the algebra, but I like it in words better, is the price if yields decline minus the price if yields increase. So they've got it. Here's the price if the yields decline, 99.3. And here's the price if the rates increase, 89.7. Now the numerator is easy because the number always has to be positive. So you know when they're giving you the data in the question, it's the bigger number first, okay? So this is the way that I often remembered it, is that I don't have to even remember the formula price if yields decline minus the price if yields increase. The TED way is just to remember big number first minus smaller number, because we want the numerator to be positive. Okay, I'm just trying to simplify it for you. And then you can see here, the denominator you absolutely have to memorize. It's the 2 times the change in the yield. And what is the change in the yield? Well, they gave it to you. It's the 120 basis points. Now remember, 120 basis points is 1.2%, so it's times 0.012. So that's absolutely critical that you need to memorize it. And then it's times the initial price, and they're giving you the initial price of 95.4. So again, I find these questions to be, these are the questions that I started liking and preferring on the CFA exam, because if you know the formula and you don't make a calculator keystroke, these questions become really easy, okay? And they just take a little bit of practice. So let's just bring up the calculator and work our way through it. We're going to do 99.3 minus 89.7 for the numerator. So I'm just going to write that down here, 9.6. And then for our denominator, just going to bring up the calculator again. It's going to be 2 times, and as I said, just don't make any calculator keystrokes, 120 basis points, 0.012, that's 1.2%, and times by the initial price. And again, they've given us all the variables. This is just memorizing the formula. 2.2896 divided by 2.2896, okay? So I'm just going to 9.6 divided by 2.2896. 4.96. And the reason why I want to do the calculation, I want to show you that it's giving you the whole number. Okay, we're not having to make any adjustments. It's 4.192872, and that's giving you the 4.2%. Okay, so that's it. The correct answer is B. Fairly easy. The price if the yield declines, big number, minus the price if the yield increases, the smaller number, divided by 2 times the change in the yield. So you have to be careful. We're not talking about here, that's the definition for duration. It's the percentage change for 100 basis points. We're not using the 100 basis in the denominator. Just be careful, because we're looking at the change in the prices from the 120 basis points. So that's the number that we use in the denominator times the initial price. So the price if yield declines minus price if yields increase, divided by 2 times the change in yield in decimal, that's why I wrote in decimal, times by the initial price, boom, 4.1928, closest to B, 4.2%. I think you'll find that these questions are actually quite easy. Properties of bond duration. So now we're going to move on to the formula to calculate effective duration. Okay, so let's have a look. Another approach to assess the interest rate risk of a bond is to estimate the percentage change in price given a change in benchmark yield curve. For example, the government par curve. This estimate, which is very similar to the formula for approximate modified duration, is called effective duration. The effective duration of a bond is the sensitivity of the bond's price to a change in a benchmark yield curve. So the formula to calculate effective duration, you can see in the numerator we've got the price if the rates fall minus the price if the rates increase, and the denominator though is 2 times the change in the curve times the initial bond price. Okay, so you can see the difference between approximate modified duration and effective duration is in the denominator. Modified duration is a yield duration statistic in that it measures interest rate risk in terms of a change in the bond's own yield to maturity, change in yield. Effective duration is a curve duration statistic in that it measures interest rate risk in terms of a parallel shift in the benchmark yield curve, which is a change to the curve. So you can see I've brought up the formula now for the modified duration on the right-hand side, and that's why I've used bold in green and bold in red. We've got to get the differences. The numerator is the same, that's easy, but the denominator is different. Okay, so we have the denominator for the approximate modified duration, 2 times the change in yield times the initial bond price, but for the effective duration it's 2 times the change in curve times the initial bond price. So let's just do a quick practice question here to help consolidate our understanding. The table below summarizes the yields and corresponding prices for a hypothetical 15-year option-free bond that is initially priced at yield 7%. So we see the yield 6.9%, price 100.9254. Of course, with the yield at 7%, the price is par. Okay, yield at 7.1%, the price is 99.0861. So the question is, using a 10 basis point rate shock, the duration for this bond is closest to A, 4.6 years, B, 7.5 years, or C, 9.2 years. Okay, you can see in this case they're looking for the duration of the bond. It's the years, so we're using the effective duration formula, where we can see in the numerator it's the same. It's just the big number minus the small number, which is from the price if the rates decrease versus the minus the price if the rates increase. Okay, to be clear. And in the denominator, it's 2 times the change in the curve times the initial price. You can see the initial price here was par. Okay, so we can see here that's 100.9254 minus 99.0861 in the numerator. So let's just bring up the calculator very quickly. 100.9254 minus 99.0861. So I've got 1.8393. 1.8393 for my numerator. And for my denominator, just going to do the calculation very quickly. Now we can see here it's a 10 basis points rate shock. So We know 100 basis points is 1%, so 10 basis points is 0.001. You got to make sure you get your decimals right. Another way to look at it, you can see here 7% to 7.1%, so that's 0.1% change. I've got my decimals right, okay? So let's just leave that on the calculator. I'm going to multiply that by 2 and multiply by the original price, which was the par. I've got 0.02, okay, 0.2. Sorry, 0.2. So then 1.8393 divided by 0.2, and we've got 9.196. So it's closest to C, 9.2 years. Okay? So that's the calculation for the effective duration. Now I'm just taking a screenshot from the text, and this highlights the point that I was making, that sometimes the question is presented to you a little bit differently. Okay? So this is going to be the same type of calculation to calculate the effective duration, but in this case they're giving you the interest rate assumption, 4%, 5%, 6%, but they're giving you the present value of the liabilities. They're not giving you a price. They're giving you it in Great Britain pounds. They're giving it in dollars. So the present value of the liabilities at 4%, 973.5 million Great Britain pounds. At 5%, 926.1 million pounds, and at 6%, 871. And it says compute the effective duration of the pension scheme's liabilities. Okay, so we can see, I'm just going to scroll down here, you can see that it's fine. We're using the value, okay, if the rates go down, so that's the 973.5. They're not using a price, okay? They're just using the, in terms of dollars, minus the 871.8, so it's the same, but they gave it to you dollars instead of price. And that's why I said you got to do as many practice questions as possible, because you'll get something presented to you in a way that you haven't seen before, and it can create some confusion. If you see it a second time, you say, oh, wait a minute, I've seen that before. You know, as I always say, fool me once, shame on you. Fool me twice, shame on me. And that's, again, a perfect example why I always say you need to go back to the official curriculum and review all the blue box examples and the practice problems at the end, okay? And then it's really easy because you can see this is a 1% change, so it's 2 times 0.01, and then we're timesing by the 926.1. Becomes a very easy calculation, equals 5.49 years, okay? So again, we didn't have prices, we had dollars, but the calculation is exactly the same. It's just been presented to you a little bit differently, and we see that time and time again throughout the CFA program, okay? And that's why do as many practice problems as possible, and you start to see things more than once, and it becomes easier and easier, okay? So we're just going to finish this LOS as we often do with one last practice question. A portfolio manager uses her valuation model to estimate the value of a bond as 125.482. Using the same model, she estimates that the value would increase to 127.723 if interest rates fell 30 basis points, and would decrease to 122.164 if interest rates rose by 30 basis points. Using these estimates, the effective duration of the bond is closest to A, 2.22, B, 7.38, or C, 14.77. Okay, the correct answer is B. It always seems when in doubt, guess B. We get a lot of questions where the correct answer is B. Anyhow, the correct answer is 7.38, and so it's asking you to calculate the effective duration. So we know it's the price if the bond if the rates decrease minus the price of the bond if rates increase. But as Ted always says, it's the big minus the small number in the numerator, and they're giving you, there's the big number and there's the small number. Okay, I'm not even going to bring out my calculator in the interest of time. And then for the denominator, it's the 2 times the change in the curve, and they're saying 30 basis points, okay? So in this case, the only mistake you need to be careful of, just getting the decimals right, it's 30 basis points. Remember, 100 basis points, I always do it like this. This is 100 basis points is 1%. So if it's 30 basis points, it's less than 100, I need to put a 0 there. It's going to be 30, okay? Sometimes I even write it out like that. You know, when you're in the exam conditions and the adrenaline's going, Always write out your steps. Just check and double check. Make it right, okay? Anyhow, so it's going to be 2 times, and we have the initial price. Here, that's the uses the valuation of the bond. So 2 times 125.482 times the 0.003, and you get 7.38. Anyhow, as I said, I'm not going to bring out the calculator. You can calculate the numerator and the denominator there. It all becomes, now you're saying, that's quite easy to calculate the effective duration or the modified duration. And with that, that's the last slide for this LOS. Thank you.